Okay, so in the last video, we looked at how we would do addition and subtraction tasks in LMC. So this is all the code, all the instructions that we have seen so far. And the last two, we had the add mnemonic and the submnemonic. So you can add a value from memory into the accumulator, or we can subtract the value stored in the memory from the accumulator. So this is where it starts to get a bit more complex, maybe slightly less straightforward. So we need to introduce looping or branching. It's not always necessarily looping. So this instruction, go to or branch always, the mnemonic is BRA, and then followed by a variable name. So again, it's the same thing as the add, subtract, load, and store. You can put a variable name to tell it which instruction you want to go to. It's slightly different. I'll show you how exactly that works. So it updates the program counter to the memory location referred to by the variable given. So we are referring again to a memory location by using a variable name. And the program counter, once this instruction will run, it'll change the program counter to that memory location, so to that instruction. So after the memory location has been loaded into the program counter, that memory location will be executed. So it's not just going to the next instruction automatically. You can make it go to whatever instruction you would like it to go to. So it's branching away from the normal progression, and you can make it go to anywhere you would like to in your program. So, looping activity. First one is create a program which allows the user to input numbers indefinitely and outputs each number. So I think I'll do this one with you guys, and then the second one I'll let you have a go at it. So the first one, create a program which allows the user to input. So I know I'll need an input instruction. And it says indefinitely and outputs each number. So indefinitely tells me that I don't want it to stop. So we won't actually need a halt instruction for this program. But I also want it to output every number that I've input. So I need an input, I need to output it, I need to repeat it. So it's only 3 steps, 3 instructions we actually need. So in LMC, I need to take an input, I need to output it, and then I need to branch, so branch always back to the first one, the first instruction. Now, you need to give a variable. Actually, if you don't put anything in, you can see here the default is to go back to the start. Because I didn't put a value after BRA, it defaults to go back to instruction 00, which is the input. And actually that works. That's what we wanted to do. But the better way to do this, because I want to always go back to this input instruction. That is the first instruction I want to load again, or I want to execute again. So what you can do is you can label the instruction you want to go back to. So I can call this start, or maybe I can call it actually input. And then I just tell the BRA instruction which label I'm going back to. So now I've labeled the first instruction as input. When I reach the branch always, it's going to go back to the memory location that I've labeled. So essentially what I'm doing here is, because input is on the, it's stored in memory location 00. Remember, it's stored here. That's the input code. I'm basically saying, all right, we're going to label this box as input. And then when I get down to the BRA, always branch back to the box that is labeled input. So it's going to go back to box 0. So if I show you running step by step, so it's taking the input, it's waiting for my input now. If I put 10 in, it then has 10 in the accumulator. The next instruction is to output it, so 10 goes into the output. And if you watch here, the instruction went back to 0 and it's asking for an input again. So that BRA instruction in here, 600, the 6 means to branch always, and the 00 is telling it to go back to memory location 00, which in our code we've named, or we've labeled in as input. Okay, and it's always a good idea to do that. The reason being, if I can reset this. If I wanted to always go back to 0, 0, okay, I could write it like that. I could get rid of the input. But if I then wanted to change my code, I remember, oh, actually, I forgot to put something at the start. I don't know what it could be. Maybe I put a different input and a store. It doesn't make a difference what I'm putting here. Now, branch 0, 0, because I've changed the start, is actually going to go back to this input. But maybe I only wanted to go back to this input instruction here. So if you label it as input, then you don't need to manually change the value you put after BRA every time. Even if I add or change this, it doesn't matter. It's just looking for that label. It's not looking at the number that the instruction appears in the code. So that's why it's always a good idea to put a label for the instruction you want. Okay, and then when you run it, you can see it takes an input and outputs it. Takes an input, outputs it. And this will just repeat forever for as long as I want the program to run. So that's the first task. Now I'm going to see if you guys can do the second one on your own. So this task is to create a program which allows the user to input numbers indefinitely and outputs the running total after each entry. It's not an easy task. Think about what would you need to keep track of. Are there any values or variables you need to keep track of here? And how would you do that? So pause the video, have a go, and then come back to this and I'll show you how to do it. Okay, so in order to do this task, I know I'm going to need to keep track of the total because I need to output the running total after each number I enter in. So I know I'm going to need to keep track of the total. I also need to be taking inputs repeatedly. So this is not going to stop. There won't be a halt instruction. So it's very similar to this code we've done it before, but I need to keep track of the total. So what I'm going to do is define a variable called total. So it's going to keep a memory location for me there, where I'll keep track of the value of total. I take an input, and then I add the total to it. Now, there's one thing missing here. If I take an input and I add the total to it and output it, say I entered in 3, my total is 0 to start off with. 3 plus 0, it outputs 3. I branch back to the start. If I put in 5, it'll be 5 plus 0, and it outputs 5. So the problem here is the total isn't updating. I'm not updating the total every time I add the number to it. So after I've added the total to the number that's been input, so say the total is 0, I input 5, add them together. I then want to store that as my new total. So I want to update the value of total. So store in total. And then the next time it loops through, so it goes back to the input, it's going to add that to the updated value of the total. So let's see if this works. So if I put in 5, it's output 5. If I put in 10, it shouldn't output 10, it should output 15, 5 plus 10. Okay, it does that. If I put in 3, it should be 18, and so on. So it's keeping track of a total, and every time I put an input in, it outputs the running total. Okay. So there are other choices for branching. You don't always have to use a branch always. So another option is branch if 0. So it does the same thing, but only this is where it introduces selection and if statement. You might be familiar with if statements in other languages. They're not as easy to do in assembly language, but you can still do them. So the mnemonic for this is BRZ and a variable name afterwards. And what it does is it updates the program counter to the memory location referred to by the variable name you've given. So it does the same as BR8, only if the value in the accumulator is equal to 0. Okay, so it carries out this instruction. It'll go to the place that you've told it to go to branch to, only if the current value in the accumulator is 0. If it's any other value, it'll just ignore this and move on to the next instruction. You've also got another choice, which is branch if 0 or positive. So this one's BRP. So it updates the program counter to the memory location referred to by the variable given if the value in the accumulator is 0 or positive. So what this does is it lets you make decisions based on if a value is negative or positive in the accumulator. And that is how you can make if-else statements in LMC. So after the memory location has been loaded into the program counter, that memory location will be executed. But it'll only do that branching if the value in the accumulator is 0 or positive. So using this, we can look at comparing values in LMC. So in Little Man Computer, we don't have if statements like we have in Python or other languages for comparisons. The only way to branch based on a condition is to do a subtraction and then branch based on the result. So here's an example program. Now, what the program does, it's not a useful program because the values are always 2 and 5. So what does it do? I defined 2 and 5 at the bottom. So you can see I've given the values 2 and 5. And the program loads the number 2, subtracts 5 from it, and then this branch, if positive, if 0 or positive, is checking if the value, if I take 2 and I subtract 5, if that value is positive, so 2 minus 5, then I'm going to branch to the instruction that is labeled output 2. So I'm going to branch down to this instruction here, output 2, where the instruction is load 2. So that only happens if 2 is more than 5, which obviously is not true. But if it was, it would jump down to here, and then it'd load 2, output it, and halt. So this program is telling you which number is the biggest, and it'll output the biggest number. But because 2 is never more than 5, the value here is going to be minus 3. It's going to be negative. So this line here, branch if positive, just gets ignored. So we move on to this instruction where I load 5, I output the number 5, and I halt. So it's basically showing me, it's a program that's working out which number is bigger, 2 or 5, and then outputs the biggest one. Okay. So you can have a look at that. If you didn't quite get my explanation, there's some more information on the screen there. But using that, you should be able to do this task now, where you create a program which allows the user to input 2 numbers and outputs the smallest number. So remember, this one is outputting the biggest one of 2 and 5, but you don't have to use the values 2 and 5 all the time. You could use a user's input and work out which one is bigger, which one is smaller, sorry. So there's a hint here. If you do A minus B, so the first number take away the second number, and the answer is positive, then A is bigger than B. The first number must be bigger. If I put in 5 as A and 3 as B, the answer to that would be 2, which is positive. Then that means that A, the first number I said, which is 5, must be bigger than B. So 5 is bigger than 3. Okay, so I want you to have a go at this. This is where the tasks start to get more complicated. Have a go and then come back to the video and I will show you how to do it. Okay, so this isn't the easiest code to do, but let's go through it step by step. So first of all, I need to allow the user to input 2 numbers. Okay, so we might input and store them both. And we'll see if we need to do that as we go through the code. So we should be familiar now with inputting and storing a value. So I'm going to store first. And I'll do the same input and store second. Now, one way you could do this is think of it just as loading the first one. I load the first number and I subtract the second from it. So load the first number, subtract the second. So then the value from that will be in the accumulator. So that's subtraction. So I want to know if that value in the accumulator is positive, then that must mean that first is the biggest number. So if it's positive, branch if positive, I know that the first is the biggest number. So I actually want to output here the second number. So maybe I'll output sec. And then somewhere down here, I'll write that label telling it, if the value is positive, I want you to skip down to this instruction where I'm going to load the second number, output it, and halt. So let's go through that again. So I've got the inputs and storing, then I load the first number, subtract the second, and then if the value of that, if the answer of that subtraction is positive, that means that the second number must be the smallest one. So I want to output the second number. So I jump down to this line where I load second, load second, if I can actually type, and output it. But what do I do if it's not positive, if it's negative? Well, then it's just going to carry on. It's going to ignore this instruction. So the next instruction, the next line of code should be, what do you do if the value is negative? Well, if in this subtraction, if the value is negative, the answer, that must mean that the first number is the smallest one. So I want to output the first one. So I load first, I output, and I halt. It's really important that you remember to put halt there, because otherwise what will happen if I don't, it'll carry on and it'll do these instructions as well anyway. So I put in a halt. And there's one more thing I need to remember at the end, which is to do the dat instruction. So I've got two variables. I need to do first dat and second dat. Okay, so there's the code done. It's not the most efficient code yet. I'll show you a slightly better way of how to do it, but we'll just check that it's working. So I'm going to enter in two numbers. Let's do 2 and 5. So the smallest one was 2. So it should output the first number. So let me just slow it down. Oh. So I've input 2 and 5. So you can see I've stored 2 in box 13 there. So that's my first box, and 5 in my second box, number 14. So now it's loading the first number from box 13, which is 2, into the accumulator. Now it's going to subtract the second from that. So it's getting the instruction, decoded the instruction, and it says subtract the value that's in box 14, second, from the first one. So 2 minus 5 is minus 3. So the value here is negative. So this line of code now, it only does this if the value is positive or 0. So it's not. So it's going to ignore this, and it moves on to the next instruction, which is load first. So just speed this up now. So it's going to load first, output it, and halt. So it loaded the first one, fetches the output instruction, and then outputs 2, and it's going to halt the program now. Okay, so it worked out that 2 was bigger than 5. Let's do it the other way around. If I put the biggest number first, 5, and then I put 2. I'll just slow it down before we go ahead with this. So again, I've input the 2 numbers. They're both being stored at the moment. So 5's already in there, and 2 is now in there as well. Now we're going to load the first one. And we're going to subtract the second from it. So that gives us a value of 3. So now the value in the accumulator is positive. So the next instruction is, if what's stored in the accumulator is positive, jump down to the instruction output sec, which is stored in box 10. So you should see now, when it runs this instruction, oh, see it fetched from box 10. I was a bit slow then. And what that tells me to do is to load the second value, which it is now done. It's loaded 2. And then finally it halts. No, sorry, it outputs it and then halts. Okay, so that's how you could solve that. Now there are better ways of doing it. You might want to have a think about it first before I show you. But we don't have to load first here. We can do it the other way around. Because second is already in the accumulator, what we could do is actually we don't need to we don't need to load first. We can do it the other way around. So we can just from second subtract first. Now, obviously, the logic now is the complete opposite direction, the complete opposite way around. So if I have second taken away first, and the value is positive, then the smallest one must be first. So I actually want to output first here. So what I need to do is swap around first and second. So I want to output first, so I load first and output on hot. And if that value was negative, if the second number take away the first number is negative, that must mean that the second one was the smallest. So I need to change this to second. So you're saving, I think, a line of code there. I didn't see the last code I wrote, but I think it's a line of code. Okay, so that's how you would do that program. Task 2, so we create a program which allows the user to repeatedly input 2 numbers and checks if they're equal. Only output the number if they are equal. Okay, so another quite tricky one. Think about if you have an equal number and you take it, if you have a number and it's the same as another number, if you subtract it, what would the answer be? So have a go at that program and I'll show you. Okay, so to do this one, it's the same kind of thing. I'll just get rid of these lines. Take 2 numbers in, subtract the first one from the second one. Now I need to check if they are equal. So if they're equal, that means second and first are the same value. So I need to use here, it means the same value, and that means that when I subtract them, the answer will always be 0 if they are equal. So branch if 0, BRZ, and what does it want us to do if they're equal? Only output the number. So because they're both the same, if they're equal, we can output whatever one we want to output. So we'll jump down to, didn't want to do caps, output. So I'll maybe load first and output and halt. Oops. Now, what do I do if they are not equal? So allow the user to repeatedly input 2 numbers and checks they're equal. So we don't do anything. But it says to repeatedly allow them to do this. So here, if they're not equal, it'll move on to the next line. We want them to be able to keep repeatedly inputting the numbers. So we want to put in here, branch always back to the first input. So I'll put input there, and I'll label the first line as input. Okay. Now, let's just read this task again. Create a program which allows the user to repeatedly input two numbers and checks if they're equal. Only output the number if they are equal. So actually, we don't want a halt. We want this to carry on going forever. So I can take this out and replace it with another branch back to the input. So take an input, store it as first, take an input and store it as second, subtract first from the second, and then if they are equal, that means they're 0, we'll branch down to the output instruction, which I haven't labeled. And as you can see, I should have noticed that because half the code isn't there. So this is the output instruction. Okay, now that all the code is there, so it should be okay. So if they're equal, I jump down to output, where I output the number. Oh, no. I made another mistake then. I want to load first, and then I output it. So you can see this is quite tricky writing LMC programs when they start to get more complicated. So once I've worked out they're equal, I jump down to here, I just load either one. I could have put second there if I wanted to, and I output it. And then, because I want it to repeatedly happen, I go back to the input instruction at the start. But if they weren't equal, so if it wasn't 0, it'll carry on to the next instruction, which is always branch back to the input instruction at the start. So it doesn't output anything, it just goes back to the start here without it outputting. Okay, so that code would work. Again, there's another way of shortening this code because we don't actually need a second instruction. Once you've input the second number, it's already in the accumulator, so we can just subtract first from it. So this line and this line, second dat and store second, we can leave out. I take an input, store it as first, we take the second input and then subtract the first from it. Okay. So if I run this, I put in my first number 5, put in my second number 2, so they're not equal, so it doesn't output because the value that was in the accumulator was -3. It wasn't 0. If I put in 5 and then I put in 5, you'll see this time the value was 0, so it outputted it. That happened quite fast. Okay, so if you watch the accumulator, if I put in 10 and I put in 10, you'll see the value goes to 0 and then it outputs 10. Okay, so that's that task done. Number 3, create a program that repeatedly takes in inputs and only outputs them if they are 0. So repeatedly takes inputs and only outputs them if they are 0. Okay, so how would we do this? Well, that's actually quite simple. Much simpler than the rest. Probably should have gone before. Take an input. Branch is 0 to output. And my output is just going to output. And it repeatedly wants us to go back to the start, so branch back to the input. What do I do if it's not 0? Nothing. I just branch back again. So I put another branch always here. Back to input. I think that would work. I take an input. If the input is 0, output it, then branch back. If it's not 0, just branch back here. I think that would work. Let's run. If I put in 5, didn't output. Put in 3, doesn't output. Put a negative number, doesn't output. If I put 0, it outputs 0. Every time I enter 0, it's going to output it. Okay, that was I think an easier one than task 2. And then the final one, task 4. Create a program which outputs everything except zeros. So think about this. Try and adapt the program, the third program. You should be able to get this working. Pause the video and then come back to me. Okay, so I want to do the opposite. I don't want to output zeros. I want to output everything apart from zeros. So if it's 0, I don't want to output. So if it's 0, I just want to go back to the input. So I can just put input here. If it's not 0, and I get to the next line, then I want to output whatever it is. So out. And then once I've output it, I branch always back to the input. I think that would work. Let's have a look. So I put in 5. It took an input 5. Was it 0? No. So move on to the next line, output it, and then always branch back to the start. If I put in 0, it didn't output it. I input 0. Is it 0? Yes. So jump back to the line that we've labeled as input, which is jump back here. So it never reaches output when you type in 0. I put in -10. Oops. I put in equals 10. Then -10 isn't 0, so output and then branch back. Okay, that's a nice little program. Straightforward. Now, do I want to do this? Okay, challenge task. This is a bit more complicated, and I'll probably make a lot of mistakes when I'm doing this, but let's just try and see what we can do, and then obviously debugging program is a nice thing to try. So have a go at that. It's not easy, and there's quite a few things you'll have to do. It's the reason that's why it's called a challenge task. And then come back and I'll have a go myself. Okay, so what do we need to do? I need to take in 2 values and work out the multiplication of them. Now, when you're multiplying 2 numbers, basically what you're doing is you're taking a number and then you're telling it with the other number how many times you want to add it to itself. If I do 2 times 5, I'm basically saying take the number 2 and add it to itself 5 times. So I'm saying 2 plus 2 plus 2 plus 2 plus 2. That's 5 2s, so I'm getting 10. And that's how you want to actually do this in this program, because there's no multiplication function. You're basically counting how many times you add a number. So I need to take 2 inputs. That's the first place to start. Input, store as first, maybe, and input, store as second. Now, what I'm going to need to do is I'm going to add the first number to itself the amount of times that the second number. So I'm going to need to actually use a loop here, which isn't going to be nice. So I'm going to repeat. I need to add first. Oh, sorry. I need to load first and add it to itself. And then I can overwrite it. No. Do I want to overwrite it here? I think we'll also need an answer, a variable for maybe the answer or result. So I've loaded first, added itself to it, and stored it as a result. Then what I need to do is take 1 away from second. So I need to subtract 1 from second. So I need to load second and sub, and I need to take away 1. So the only way to do this in LMC is I need to actually define a variable down here. So I'll do first and second as we're used to. But I also need to define a variable called 1. I'm going to give it the value 1. So I can sub 1 away from second. And once I've done that, I want to repeat this until the second number, which obviously is counting down, until it reaches 0. So I need to check if the value is 0. So I should store that as second to make sure it updates every time. And I check, is the new value, after I've taken 1 away, is it equal to 0? If it is equal to 0, then we need to branch to the output. So I'm going to put an output instruction where I load the result, I output it, and I halt. But if it's not 0, I want to repeat some of the steps. I want to go back to loading first. Oh. No, I want to go back to loading result. Store. So I'm loading first, storing it as my result. Then I load result. And then I add first. Okay. So basically what I've done there is when I first take in the values first and second, I'm also storing first as a result. So that's counting as adding 1 to itself. Okay, then I load result, I add first to it. So I'm adding it once, storing that as a result, so overwriting it. Then I load second, take 1 away from it. Obviously this is working just as a counter, it's counting down. Taking 1 away, updated that, and then checked, has that value reached 0 yet? Have I added that number this amount of times yet? If it's 0, then I can just go to output. If not, I want to go back to where we loaded the result. So I want to branch always back to the instruction for the loop, where we start the loop. So I'm going to call it loop. I'm going to put that there. Now, is this finished? So this obviously is very hard to debug. I've missed something. So it's on this line. I haven't defined result, and I haven't defined result down here. So result dat, so that it knows I need a variable called result. Now all the code seems to be there. If we run this, let's just see if it works in the end. So if I do 2 times 3, this hopefully gives us 6. It might give us 1 more. Okay, so it's given us 1 more than we wanted. It's done 2 times 4. And I bet if we run it again, I do 3 times 4, which should give us 12. I reckon it'll give us 15. Oh, let's give us 18. 3 times 4. Why has that happened then? I've obviously made a mistake somewhere. So actually the reason it didn't give me 15 as I expected last time was because I hadn't clicked reset when I assembled it into the RAM. So I'll just show you, if I did 3 times 5, it should give me 15, but I'm expecting 18 now. Yeah, so it gives me 1 too many. It's added 3 1 too many times. So the way of fixing this would be, instead of adding the number, then subtracting the result, so it's an off by 1 error really, what I can do is I can subtract 1 and do the check here before, so subtract 1 from the second number, count that down before I actually do the the actual adding. So if I just swap these around, this step, I put it above this one. So now what have we got? Well, if when we go into the loop, we load the second number first, subtract one away. So we're counting how many times, that's another time we've added it. If it gets to 0, before we even add the number, we're going to jump back. We're going to jump down to the output. If not, then we add the value. Okay, so then we do the adding. So let's run this. Hopefully it works. So 3 times 4 will do. 3 times 4. And it gives us 12. Good. Let's just check. Click reset first, then run again. See if it works. If we do different numbers. And let's put 5 times 2. That gives me 10. So basically I'm getting 5 and I'm adding it to itself. Well, there's 2 5s adding together. If I do that again, I've got 10 times 3. So I'm going to add 10 3 times. Okay, and that is a program that will do multiplication for you in LMC. It's not easy. It took me a while to work out what I'd done wrong. It's not a nice language to debug, but hopefully that has helped you guys, if any of you did try it. Hopefully you managed to do it better than I did. Okay. So again, that was a challenge task. Don't worry if you didn't manage that. And I'll show you one more video, I think, on this topic, which will be all about how you can use this to make sequences that you would be familiar with from GCSE mathematics. Okay, so catch that in the next video.